Hi, my name is Louis-Philippe Querel, and I'll be presenting the work that was done with Peter Rigby on building historical commits to run static bug finders and using those warnings to try to improve statistical bug prediction models. So, first of all, building old historical commits is complicated. Through our process, we identified three main types of issues that we addressed. The first one were issues with the build tools. For example, while newer releases of the Java Development Kit or JDK are supposed to be able to build older commits, older code, we observed that this was not always the case. So as part of our tool, we added a mechanism by which we would use older major releases of the JDK to build older versions of code with success. We also applied the same principle to Maven with positive success. The other type of issue we had was with missing dependencies. In some cases, it was just a question of adding additional repositories that had those missing dependencies. But in some cases, developers were using snapshot releases of libraries that had since been deleted. For those, we substituted the snapshot releases with the most appropriate promoted release of that library. Finally, the last type of issue we had was memory issues during the build process. To correct that, we increased the memory available during the build process, which resulted in more build success. So prior studies have tried to build historical commits and to run static bug finders. For example, Tofino tried to build over 279,000 commits, but had a build success rate of slightly over 38%. However, in their case, they were not trying to run static bug finders as well on them. Nanda didn't try to build a historical commit and would just run the static bug finders on more recent commits. Finally, Ramet and Tang, who tried to use historical releases, only had a limited number when running their static bug finders. So we built a tool called Warnings Guru, which allowed us to attempt to build over 45,000 commits, and we had a build rate of about 78.5%, which is double what was done prior. In terms of age, the oldest commit we were able to build as part of the study was 10.2 years. Once the commits were built, we would run the static bug finders on them, which were JLint and find bugs. And we had a mechanism in place to link back the warnings to the unbuildable commits using git blame. As a result of that, we identified that 58.5% of the files in commits contain warnings. However, only 12.8% of those actually introduce new warnings. We took the results from Warning Guru and implemented it in a tool that allowed to visualize all the different warnings that were associated to modified files and presenting the new warnings with the tool that reported it and the security classification and original commit. The tool we integrated into was CommitGuru. CommitGuru is a tool that implements the ASZZ bug prediction algorithm to do statistical bug prediction, and it uses different measures of the code to build up a prediction model. Going with the bug prediction model, we tried to determine whether or not warnings were a good predictor of bugs. Building logistic regression of commits that introduce bugs, we had three models: the commit guru, which was our baseline, the warning model, and the combined model. Our baseline was able to explain 19.5% of the deviance, while the warnings were a lot lower at 13.4%. Combining both those together resulted in a deviance explain of 22%. However, warning counts seem to be a poor predictor of bug introducing changes and explains similar phenomena as to the commit guru measures. Finally, we also completed a preliminary user study to assess the perceived usefulness of warnings by developers. We sent out surveys to developers who had committed changes that introduce one or more new warning. We had a response rate of 17.9% and obtained information concerning 81 warnings. Out of those, we were able to extract two main results. The first one was that the tool does have an impact on the perceived usefulness, so they're not equal. The warnings that were reported by find bugs were perceived as more useful by the developers when compared to JLint. We also tried to assess the impact of time on the usefulness of the warning, where we calculated the time between the original commit and the response from the developer. And we determined that the faster the developer is made aware of the warning, the more it is perceived as useful. In conclusion, we introduced Warnings Guru, a tool which allows to build historical commits and extract static warnings from bug finders. However, we think it would be better to integrate the bug model into a CI pipeline. Warnings Guru could be used to build more commits in other studies. However, we need to consider the virtualization of the build to improve build security. And while warnings can be used to predict bugs, they're not as effective as other methods. And finally, our preliminary user study determined that the static bug finder and the recency of the warnings has an impact on their usefulness. However, additional research would be required. Our code can be found at code.warnings.guru. Thank you and have a good day.
Hi everyone, another time in this Q&A session, and now is presenting a negative results, but a replication one too. So great pleasure to have you here, Louis-Philippe.
Thank you.
So in your vision, what are the possible future directions to commit warning research?
So my thought when it comes to the future direction is like in cases where it is important to be able to build historical commits. We need to be able to do it to increase the percentage. We were able to increase it, but I think it would be better and possible to increase it even more. And overall, in terms of all of the commits, it's a question of like improving the performance and making it so it doesn't take as long.
Sure. And Anita did two questions. I will try to do the second one. Where their classes are warning, and where any particular type of warning that are of higher utility?
So we didn't target specific like classes of warnings. The tool that we used allowed for the classification of security versus like non-security warnings.
Sure.
And if I recall correctly, we did notice a difference, but I would have to double check the results specifically. More research would like to redo it. We could potentially do a more granular analysis based on the warning class, but
Absolutely.
that wasn't done as part of this paper.
Great. And as a negative replication results, if you could restart this project, what would you do differently?
So while we are very proud of the number of commits that we were able to build to run the static analysis, the static bug finder, sorry, we found that it was not actually used that much. So we think it would be better to just integrate it into a CI pipeline so that it is more useful for the developers.
Oh, great. And how to collaborate with your research project, Peter Philippe?
So given that we were able to increase the number of commits that were buildable, for all types of research that require buildable commits and historical buildable commits, the knowledge and the expertise we acquired through buildings Warnings Guru and our research would be applicable in this case, potentially.
Great. And it's congratulations for replication and negative results, and see you around in the discussion room. See you. Bye-bye.